here we go. We're going to take this Chapter 2 practice test, see how we do on it, see how Mr. Benson does on it, and then hopefully this will help you figure out what little mistakes you made when you were working with this test right here. So let's just get at it. Enough talking. Let's just do this here. Okay, so here it says identify the transformation from the parent function f of x, which is equal to x squared, to this crazy looking function right there. We got to identify the transformation. Well, this function right here is a parabola, so if you were to graph this function, it would look something like this. And so we're just going to try to figure out what happened to go from here to here. Well, here's the formula that you got to remember. You got to remember this formula: y equals ax plus h squared minus k. Now, there's actually two other different formulas that are very similar. There's one where it's the square root, and there's one where it is the absolute value. The only difference is the square root would be right here, and the absolute value would be right there for that. But that's the only difference. It does all the same thing. So let's not get confused about that. Let's just focus on this right now. First off, we got to figure out, what does this a do? Well, I'm going to tell you what this a does. The a does three things. The a can flip it if it's negative. Okay. It can stretch it if the number is greater than 1, or it can compress it if the number is less than 1. And what I mean by stretch is, like, if I were to graph a stretched version of this function right here, stretch will make it look really skinny like this. And when I mean compressed, it will look something like really flat like that. So this is a compressed version, and here's the stretched version of it. Okay, so that's what the a does. Now the h right here, this does something too. That actually will shift it left. Oh, that's not use yellow. That will shift it left if it's positive and right if it's negative. Okay, that's what the h does. And the k is the easy one. Oh, this should be plus. Make that a plus right there. The k will make it go up if it's positive and down if it's negative. Okay, so now with that in mind, let's take a look at these things to answer this problem. We know that the a is 3. Okay, so if we look at it, we know it's negative, so it's going to flip it because it's a negative, and it's bigger than 1, the absolute value. Think about the absolute value is bigger than 1. So it's stretching it. So we're going to look for something that flips it and stretches it. So we've got a vertical stretch. It could be this one: vertical stretch, vertical stretch, vertical stretch. And flipping. Flipping is the same as reflection over the x-axis. So reflection over x-axis right here. So it could be this one or this one. And then we know it moves. Let's see. Let's take a look at this 4 now. So it's one of these two. We know it moves to the left 4 because it's positive, so it's moving left 4. This one's right 4, so it can't be this one. And it translates down 2. Well, yeah, but we don't care because we already got this other part. And we'll check that and see if that's the right answer. Checking, checking. There we go. Looks good. Clear it off, and let's go on to the next one. Now remember, you don't have to watch me do every one of these problems. Actually, I hope you don't, because that would be really boring. Look at the ones you got wrong, and then watch me do those. So skip ahead if you need to. I'm going to try to be thorough, though, in what's going on here, what I'm doing. So here we want to evaluate the expression. If needed, write your answer as a fraction. That's saying if needed, which means I don't want a decimal. No decimals for this problem. No decis. Okay, so first thing, I'm trying to simplify this down. I have this 2 here. What I'm going to do is I'm going to distribute this 2 to each exponent here. The exponents are there, you just can't see them. There are 1s up there. We're going to distribute that 2 to the 1s, and we're going to multiply it when we do that. And so what I have is, I got -2, I'm going to put parentheses on it because it's very important, to the second power, and 3 to the second power. Now you'll notice I didn't put parentheses around this. When you're squaring in a calculator, you need parentheses around negatives so it does it correctly. So I just put it there just in case. Now let's finish this off. -2 to the second power is the same as -2 times -2. A negative times a negative is a positive, so we have positive 4 on top, and 3 squared is 9. So our final solution is 4 over 9. Let's put that in there and see how we get on this. 4 divided by 9. Check in. Boom, 2 for 2. This is a good one. This is a good test. Okay. Now we need to move on to number 3, and we want to identify the transformations from the parent function of this to this. Oh, this was a lot easier than the first one. The only thing that's happening is there's something going on here in front. So if we go back to our formula, y equals ax minus h plus k, we're just focusing on this a, and the a is negative, because that -1 right in front, let me erase this so you can actually read it. This -1, or this negative in front, we'll just flip it. It's called a reflection. The negative is creating a reflection right here, and so we'll just select that as our answer because it's reflecting. Of course, what you could also do is you could go on to Desmos, right? You could graph this and you could graph this and just say, hey, what happened to it? You could graph both of those. If you were on Desmos for this, and you had the parent function right here, the parent function would look like this. You would graph the other function, this one right here. That would look like this. It'd just be a reflection over the x-axis. Reflection. Think looking in the water, there's a reflection in the water. That's what I'm going for on that one. Moving on to the next problem. Hopefully I'm recording. That'd be embarrassing if I'm not recording this. Okay, here we want to simplify this whole problem right here. We're just going to take our time. That's why when you get to this, say, right before you start this problem, you say, I'm going to take my time. And I'm not going to use green because I can't see it. So take your time on this, TYT. First thing, I'm just going to draw a fraction bar because I'm going to start simplifying this. At the top, I'm going to look at the top. Can I simplify the top at all? Not really. Can't bring the y's with the x's or 2 with anything else, so my top is 2xy to the -2. Now let's try to simplify the bottom. Well, this you really can't bring in there because it's 2, but let's rewrite this on the bottom over here, x to the 3rd y squared, and now let's distribute this 2 into the -4 and that. So times x to the 4th y to the -8th. Okay, so we're at that point right now, and because we are taking your time, or our time, we're going to keep on drawing a lot of fraction bars and make this nice and easy on us. The next step, we can't simplify the top, so I'm just going to rewrite that 2y to the -2, but I can simplify the bottom. I can bring these x's together. That will get me x to the 7th because I'm going to add them. When I multiply the bases, you add the exponents. And I'll bring these together by adding them, so I'll get y to the 2 plus -8, which is -6. Okay. Now because we are taking our time, we're going to do another little fraction bar here. There's no rush, right? And we're going to now swap anything with a negative exponent. And we got a couple things here with negative exponents. We have this here has a negative exponent, and this y here has a negative exponent. So we're going to swap them over to the other side. So when I rewrite this, what I have here is I got 2x, that doesn't change. This y to the -2, that's going to go to the bottom and become y to the +2. This x to the 7, that stays on the bottom, doesn't have a negative exponent. And this y to the -6 will go to the top. Become y to the +6. There we go. We're getting really close now, guys. We're just taking our time on this. Now what we want to do is simplify top to bottom, top to bottom. So we got y to the 6 and y squared on top. I'm going to simplify these by canceling them. I'm going to cancel these 2 on the bottom, which means I have to cancel 2 on the top. But I had 6 on the top, so how many are left over on top? Oh, y to the 4th. I really can't cancel this 2 with anything down here, so that just stays there. But this x right here, I can cancel 1 on top with 1 on the bottom. But there were 7 on the bottom, so how many left there? 6 still. X to the 6. So let's put this into our answer. Make sure we know how to do this. We're going to start by putting the top in. So you're going to put 2 y caret 4, divided by x caret 6. And let's check that, see if we did all right. Fingers crossed. These are always tough. There we go. So that's how you do a problem like that. Okay. Let's clear this up and move on to problem number 5. We're well on our way. Now when I see these, a wise man once told me, his name was Sam, you should simplify the top and the bottom separately and then just divide. And I was like, that is an awesome idea. So let's just imagine this 2's not here. We'll put it back in later. And we're going to figure out what this top is. So I got 17 plus 3 squared minus 4. We're going to take your time on this one. So 17, you really can't simplify this. PEMDAS says to do parentheses first. There's really no parentheses up here other than this, but nothing to do in there. So you're really just multiplying there. So the next thing we have to do in PEMDAS is exponents, right? So we got this exponent here, so we're going to add 9 and minus 4 times 2 all over 2. It's still there. We're just taking our time. And then let's do now the multiplication division. The only multiplication division going on is right here. There's 4 times 2. So I got 17 plus 9 minus 8 all over 2. Now we're going to continue just work on the top. What's 17 plus 9? We're going to do addition and subtraction from left to right. 17 plus 9 is 28. Nope, 26. Minus 8, which would be 18. So I have 18 on top all over 2. And 18 divided by 2 is 9. So evaluate the expression using the order of operations. Our answer should be 9 when we do this problem. Let's see if it is. What? No way. Where did Mr. Benson go wrong? No way. 17 plus 9? Where did I go wrong? 17. Okay, let's do this again. 17 plus 9 is 26, right? Did I go too fast? 26 minus 8. 26 minus 8. What did I do wrong, guys? Are you guys wondering what I did wrong? 26 minus 8. 26 minus 8 would be 18. 18 divided by 2 is 9. Was this not a 2 under there? Did I forget what it was? We divided by 2. 17 was Emily, what did I do wrong? Emily's here. She's taking out a calculator right now. We're going to come back to this one, but I'm pretty sure it's 9. So I'm going to go online. I'm going to make sure that this one is counting it right, because this should be 9. I don't see any mistakes there. If you can tell me what mistake I made, please let me know. Send it to bensonr@stillwater.k12.mn.us if you can remember that. Okay. Okay, moving on. I'm going to do the one down here while Emily does the one on top, and then we'll see if we get the same thing. Okay, PEMDAS. Benson struggles with PEMDAS, I guess. Tell that to people. So, again, PEMDAS, we're going to use parentheses first. So I got 2. So I got 2 plus 11 minus 2 plus 1 is 3. So I did that parenthesis divided by 4. Okay? And then we're going to do this parenthesis right here. So it gives me 2 plus 11 minus 3, which is 8, divided by 4. Okay? So I got that. Now we're going to do multiplication and division from left to right. 8 divided by 4 is 2. So this gets me 2 plus 2. 2 plus 2 is 4. So hopefully the final solution on this one is 4. Otherwise, bears twice in a row. You figured out what I did wrong? Yes, I got that one at least.
3, not a 2 above the 3. It's 27.
Oh!
27.
Wow. Wow. So this then shouldn't be 9 because it's a 3 to the third. It should just be 27. 27 plus 17. So this is 27. 27 plus 17 is 30, 40, 44. So that should be 44 right here. 44 minus 8, all divided by 2. 44 minus 8, what is that? 36. So I have 36 divided by 2, and that is a whopping 18. Oh, no. Silly mistakes. That's why you got to take your time and really do it. But y'all make mistakes, guys. That's what the lesson was about. That's why I made that mistake intentionally. That's why I made that mistake. Emily's shaking her head. I can't believe. Okay. Moving on, next one. You're welcome for making that mistake, everybody. So here on this one, I think the biggest issue here is combining of the things. Remember, everything here is just being multiplied. And when you multiply 2 times 3, that's the same thing as 3 times 2. You can just rearrange this whole thing. So what I have here is 3 times b times 3 times b squared. Well, this is the same thing as 3 times b times b squared. Okay, see how I just arranged them differently? I took this 3 and moved it right next to that one. I took this b and moved it right in front of that. Well, now, what's 3 times 3? Well, that's just 9. And what's b times b squared? Or how many b's do I have altogether? I have 3 b's, so that's b to the third. So my final solution should be 9b to the third. Okay? I'm a little nervous though after that last mistake. 9b caret 3. That's how you put that in. There we go. Okay, back on a roll. Oh gosh. Okay, domain and range. So this function right here, it wants us to find is the graph a function, what is the domain, what is the range. So first off, to figure out if it's a function, you're going to do the vertical line test. And so I just drew a vertical line, and I'm going to take that vertical line. I know it's not vertical, but I'm going to try to move it around and see if it ever touches 2 points at once. And what I'm seeing is it never touches 2 points at the same time. Therefore, this is a function. Okay, so we can make that a function. Yes, it is. Okay, that's done. Now what else do they want you to define? Oh, what is the domain of this function? Okay, let's get rid of that vertical line. The domain of this function is how far left and how far right it goes. So if you think about it, this function right here is going down, but it's going this direction and it's going down. And it never stops going this direction. So it goes that way forever and ever. I'll never be able to draw a line long enough. So it goes that way for negative infinity. This arrow is going down, but it's also going this way forever and ever as well. And so thus it's going a domain of positive infinity. From left to right is your domain. Okay, think of that as your domain. So how would you write that? Would you write that as a parenthesis negative 0, 0, comma 0, 0, parenthesis? And whenever we were dealing with infinities, you always have parentheses here. I always use parentheses with infinities on the side that the infinities are there. So I'll try putting that in here. See what we get. Negative 0, 0, comma 0, 0. Close that off. Okay. Now the range isn't how far left and right something goes, it's how far up and down it goes. And range is bottom to top. That's how you put this. Where domain was left, comma right, range is bottom, comma top. Okay, so how low does this function go? Well, this function keeps on going down this way forever and ever and ever and ever and ever and ever. So it goes down to negative infinity. Okay, so that would be your left-hand side, negative infinity. Now, how high does this function? What's the highest point on this mountain? Well, its highest point is right here, and that's at a height of 3. And actually gets to 3, and because it gets to 3, you would put a 3, and instead of parentheses, you use a bracket like that. So that would be the range of this function, from negative infinity to 3. Negative 0, 0, comma 3, and then bracket. Let's see how this turns out. There we go. Looking good for that one. Moving on to the next set. Okay. So at this problem, I know this dot is a little bit big, but this problem is what they're asking you to do is they're asking you to take this and multiply it by that. Okay? And so when I see a problem like this, what I'm going to do is I'm going to use something called the box method to do this. It's someone's favorite in this room. Right, Emily? The box method. So the box method, you really don't need it to use it for this one, but I'm going to do it just for Emily.
Yes.
You're looking at how many terms we have here. Here we have one term there, so it's going to be 1 high. The box, and here we have 1, 2, 3, so it's going to be 3 terms long. So here's my box here, and it's 3 terms long and 1 term high. And what I'm going to do is I'm going to take this negative 5x, I'm going to put it right here, and I'm going to take this 4x squared minus 2x plus 1, I'm going to put it above each box, each term. 4x squared negative 2x plus 1. You just put 1 there. Okay. And now what to do to figure out this inside, you just have to multiply this by that to get this, and this by this to get that, and negative 5x by 1 to get that box. So let's just do that. We'll make it, let's do orange on the inside. Negative 5x times 4x, I just do negative 5 times 4 to get negative 20, and x times x squared is x to the 3rd power. Okay? And now negative 5 times negative 2 is 10, and x times x is x squared. And negative 5x times 1, well, that's just negative 5x. So our final solution, make sure you put in standard form. Highest degree first to lowest degree. So this is the highest degree x or variable. This is the next highest and this. So it looks like it's already in standard form. But the final solution is negative 20 x to the 3rd plus 10x squared minus 5x. And that's what they're looking for on this one, I hope. So how would we put that in here? We've got negative 20 x to the 3rd plus 10 x squared minus 5x. Double check it so we didn't make any stupid mistakes like we do, because we're human. We all make mistakes. It's part of life. It's what we do once we make those mistakes. I don't know if that's from a movie, but it should be in a movie. Okay. Yeah, checks off. We're good. Clearing this. Moving on to classifying the following number. This shouldn't be too bad. We just got to find the lowest degree and then work our way up. So the question is, what does this number fall under? Is it a natural number? Well, natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this one, you sadly can't simplify because these are 2 primes. So this is definitely not a natural number because it's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Onward for infinity and on. Next is a whole number. Well, whole numbers are very similar to natural numbers. The only difference between a whole number, actually I'll put some natural numbers on here just so you guys can see it. Natural numbers are 1, 2, 3, 4, dot, 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 dot. Whole numbers are almost the same. You just added 0 in front. 2, 3, 4, da, 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 da. Okay? So this one is also not a whole number because it's a fraction. We can't create it into a whole number. If you could simplify a whole number, then it would be a different story. Is it an integer? Well, integers add a little bit more, and we still have the 1, 2, or 0, 1, 2, 3, 4, da, 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 da. But you also have the negatives. So we got -1, -2, da, 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 da. So again, that is not an integer because it's a fraction. So moving on to rational numbers right here. So rational numbers, let's select no for this one. Select it. Okay, rational numbers. Rational numbers are fractions. That's what we were waiting for. Anything that can be put in fraction form is a rational number. So anything like, a number over a number, that's a rational number. But just so you know, 2 is also rational because 2 could be 2 over 1. So there's some tricky things. 2 is also rational, right? But this one is only rational. It's not an integer or a whole number or a natural number. So this would be a rational right there. Is it irrational? No, because in fraction form, anything that can be formed as a fraction is not irrational. And is it real? Yes, all these are real. So you should put yes if you ever see yes on this test for this. Push it. Let's see how we did on it. That was a lot, but I think we got them all. No, 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 yes, 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 no. There we go. Okay, moving on. Here, this problem wants us to determine which function matches the graph below. Oh, so we got this function. Well, okay, it's a parabola. I think we got this. So we got this y equals a x minus or x plus h squared plus k. K tells you the up and down, the h tells you left and right, the a is the flipper. This one didn't flip it, and it doesn't really look any different than what a normal parabola will look. It doesn't look skinny or anything. So the a, I'm just saying, is probably going to be 1. Let's see how far it went. It looks like when we started here, when we left it off there, it went to the left 1, 2. So it went to the left. Because it went to the left, it's going to be a positive, right? Because the left is positive, so the h, think of that as 2. And it went down 1. So the k is -1. So if we were to rewrite this, we have y is equal to 1 x plus 2 squared minus 1. But you don't need that 1 right there, so we'll get rid of that. Let's put that in for, let's see if we can find that, because this is multiple choice, right? Gives you a hint of what you might see on the test. Dun, dun, dun. We got y equals x squared minus 1, x squared, x plus 2 squared minus 1. Is this one? I think it is. Let's check it. Perfect. You guys are awesome. Keep it going. Moving on to evaluating. Let's clear this annotation. So, here, we want to figure out what f of 3 is and f of -2.5, and we are given this function. And really what they're saying to do is they want you to take the 3 and they want you to plug it into the x's here and see what you get. And then this is a totally different question, but they want you to take the -2.5 and take it and plug it in for that there and see what you get. So let's just do that. So we're going to take this, we're going to plug it into this function. So we have 2 times 3 squared minus 3 times 3, and then the 3 will be our orange. So we're going to put the 3 in there. So if we were going to do this, let's do a little work our PEMDAS magic. So 3 squared times 2, that's 18. minus 9, which is 9. Okay, so this first one is 9. Okay, now that that's done, we're going to clear this and we'll do the next one. Okay, so same idea. We're going to take this 2.5 right there and we're going to plug it into the x here and here and pick that and put that in there. So we have 2 times 2.5 squared minus 3 times 2.5. Purple. 2.5, 2.5. Okay, now we just got to figure out what 2.5 squared is, and off the top of my head I just can't do that. 2 times 2 and another half of 2. Wait, 2 times 2, no, that's 5. 5 and a half of 2 is, okay, 6 point, I think it's 6.5. Hopefully I did that right. So I got 6.5 times 2 minus 3 times 2 is 6. Another half of 3 is 1.5, so 7.5. Okay, and then 2 times 6 right here, or 6.5 is 13 minus 7.5. Excuse me, everyone. And then 13 minus 7.5. Math and head. 5.5. Okay, let's see if I did that one right. I'm a little worried. When I squared the 2.5, I think I got it right. Let's check it. Check it. Oh, I didn't do it right in my head. Okay. That's why, let's get the trusty calculator out here. We got 2 times 2.5 squared. Minus 3 times 2.5. Oh, it's negative 2.5, guys. Emily, check it out. It's negative 2.5.
What?
I put in 2.5. My mistake. So let's insert that negative there. I'm sorry, everyone. What a silly mistake to make. Let's put that in. Oh, what am I doing now? Oh, it doesn't matter if you squared this, it'll become a positive. We're good. 20! There we go. The answer is 20. And then check it out. This, if you had negative 2.5 and you squared it, it would become positive anyway, so you just can leave it as positive and square it. So here's our 20. Let's check that out. Okay, that's what I mean. Another lesson. You just take your time, guys. Don't do silly mistakes like I did. So really, my mistake here was forgetting to put the negative there, which really didn't matter. That won't change a thing. But it does change a thing if I don't have it there, because you would be, instead of subtracting 7.5, you would have been adding 7.5, and yeah, and then obviously this was a mistake too someplace. 13. Yeah, we won't talk about it anymore. Moving on up. But really down, because I'm moving down. But it's getting tired, guys. I could do this though. The sun just came out. It's gonna be 70 today. A grand day. Okay, is the graph a function? I'm going to do the vertical line test and test it out. There's my vertical line, not exactly vertical, but we're going to see if it touches 2 points at once. Does it ever touch 2 points at once? Negative. So thus, this is a function. Next, we're going to find the domain. How far left and how far right does this go? Well, the furthest left point is here. This is the furthest left point right there. Oh, I didn't mean to do that. Right here is the furthest left point. And it goes all the way over to here, so that goes from there to there. But this is your open circle, and this is your closed circle. So there's your domain. Your domain is from, this is what, 1, I would guess, and then this is 1, 2, 3. Since you don't have a scale, it's really tough to tell. But it's from 1 to 3. How far left does it go, and how far right does it go? Because it's an open circle, we use a parenthesis here. Think parenthesis for that. Closed circle, bracket. Okay, that's what we're going to use at those things. So the domain is left to right. We got 1, 3 bracket. It ranges top to bottom. How low to how high does it go? So this is how low it is right here, right? So we'll have an open circle there. Oh, I thought this was red. Open circle here. And how high does it go? This high. Closed circle. So it looks like if you want to write it this way, low to high. We got that and a bracket there. This is a height of 1, 2, 3, 4, 5, and then 0 to 5. So it should be something like that. Zero, 5 brackets. And let's check that out. See how we did on that. suspense. That one took a while, but it looks good. There you go on that one. 14. Oh guys, you guys struggle on this one, the subtraction one right here. So we are doing g minus f. So this function right here, this function minus this function. So let's use some color coding just to make sure we're understanding what we're doing here. Is this g minus f right here, that one. So let's do this 6x squared minus 3 minus negative x squared minus 3. Negative x squared minus 3x. Okay, and my wife says at this point you're going to stop, chop this. So you're going to stop for a second because you're subtracting. You're going to chop this one, and only in the second parentheses you're going to change all these to the other sign. So if it's negative, it becomes positive. If it's positive, it becomes negatives. These were both negative, so they'll both become positive. Now that you did that, you get to get rid of parentheses. 6x squared minus 3 plus x squared plus 3x. There we go. I got my parentheses gone. Now it's about combining like terms. And when I say like terms, you're going to look for terms that have variables with the same exponents. So I got this x squared and this x squared. I'm going to bring those together. That's going to create 7x squared. This negative 3 doesn't go with anything else, so I'm going to put that right here. And this 3x doesn't go with anything else, so I'm going to put that right here. The reason I rearranged them, here's why. You got to put them in order from least to greatest and from power wise. So this is the highest power, this is the next highest power, and constants always go at the end. So our final solution is 7x squared plus 3x minus 3. So 7x caret 2 plus 3x minus 3. Check it. 15. Only a few to go. I think I got a second wind, everybody. Okay, 15, it says identify the transformation from the parent function from this one to this one right here. Oh, so we just got to remember. So remember, we got this one right here. That's this function. This function right here took that function and subtracted 3 from it. When you subtract 3 from it, 2, 3, it just goes down 3. Which is a translate down 3. That's what's going on. And so that's your answer to this one. Nice and easy. Moving on. I like those easier ones. Okay. Clear these. Oh man, forgot about these. Match f divided by g with the appropriate domain restriction. So we're going to look for domain restrictions here. But the domain restriction is actually relatively easy once you understand it, which is obvious, right? But what you need to do is we got f divided by g, which tells me that the g is in the bottom. We got f over g. The domain restriction is when the bottom, this bottom right here, is equal to 0. How do you make the bottom equal to 0? Because you know you can't divide anything by 0. It's undefined. And because that's undefined, that creates a domain restriction. So this process for it is to take the negative 5x right here, set it equal to 0, and solve. Well, negative 5 times what is 0? Well, x must be 0 then. That's the only option for that one, so we choose 0. X cannot equal 0. Yep. I know it's equal to 0 when it's undefined, but it cannot equal 0. That's when there is a domain restriction. Okay? So let's do this other one right here. 2x minus 6. We're going to set this equal to 0. So we've got 2x minus 6 equals 0. Add 6. Add 6. I got 2x is equal to 6. Divide by 2. So x cannot equal to, can't equal to 3 in this situation. So let's choose add. X cannot equal 3. And I bet this is the only other one. But let's just make sure. What would we have to do to make this 0? 7 minus what is equal to 0? 7 minus 7 is equal to 0. So x cannot equal to 7. And that's how you do those problems right there. Let's check that out. There we go. Moving on. Oh, we got another domain range one. This one's kind of weird looking. I'm going to plow through this one a little bit faster since I've gone over it. Well, maybe not. Okay, is the graph a function? What are you going to do? You're going to draw your vertical line. Not horizontal. Vertical. You're going to take that vertical line. You can try to grab it with your hand. and you're going to move it. And you can see, does it ever touch 2 points at once? Oh, you bet it does. Look at that. There. It's touching right here. It's touching right here. So it's definitely touching 2 points at once. Everywhere you move it, it touches 2 points at once. Therefore, this is not a function. It's not a function. Okay, now let's find the domain for this function. The domain is how far left and how far right it goes. Domain is left to right. So how far left does this function go? Well, the furthest left point is here, so it looks like it goes as far as -2. And it actually gets there. So assume it's getting there. Okay? And how far right does it go? Well, it goes this way forever, so it goes to infinity. So there's your domain right there. Now let's find the range. Remember, range is up and down. So how low does this go? Well, this function is going not only this way, but it's also going that way. And it goes down forever and ever and ever and ever, so it's going to -infinity. So the low is -infinity. And how high does this go? Well, it goes up that way forever and ever and ever. So it goes up that way to infinity. So there's your range right there. Let's just plop those two things in here. Domain, we got to bracket it up. -2, comma, double zeros for infinity. And then the other one is negative double zeros for infinity, comma, double zero. And there we go. Let's check that out. Okay. These things are going well. Moving on. Okay, use the following data below to answer the following questions. Okay, so I got this data right here. We want to know is that the function, this is what I look for first. Are all the x's different? I got 0, 1, 2, and 3. They are. Okay, now we know it is a function. Okay, so check that off your list. Are all the x's the same? Are all the x's different? Sorry. If they are, it's a function. What is the domain? Well, the domain is all the x values. The 1, this, and this. Let's use color coding for this. This is your domain. Right there. That goes into the domain. And the range is all the y values. Right here, right here, right here, right here. Tell them to come back later. That's all the y values, okay? So we're just going to plug those things in. This is where you get to use those fun curly brackets. So that's right above the brackets. We got, you need to put in from least to greatest 0, 1, 2, 3. And the curly bracket, and then you got the other ones. You got 3, -2, and -3. Notice that I have them twice, the -2 twice and 3 twice. You don't have to put them in each time. In fact, you're not supposed to. So put your -2, 3, and curly bracket. I probably should have deleted this one right here, and check that. What? Did I do something wrong? What did I do wrong? Emily? I don't know. I got 3 there. I got a 3 there. I got a -2 and -2. Oh yeah, Mr. Jordan says it's counting this one wrong for some reason. I'll get that fixed. This is a bug. We'll figure that out. Clear that notation. Moving on. Okay, we're going to classify this number. First, can you simplify it before you can classify it? Well, what's the square root of 4? Just because it's square root doesn't mean you can't simplify it. Square root of 4 is actually equal to 2, because 2 times 2 is 4. So is that natural? You bet it's natural. It's a natural number. It's a whole number. It's an integer. Falls under all those situations. Remember, natural numbers are 1, 2, 3, 4. Whole numbers are 0, 1, 2, 3, 4, etc. Integers are 0, 1, 2, 3, 4, etc. But also the negatives in there, etc. Rational. Can you put this as a rational number? You bet you can. You can make it into a fraction of 2 over 1. 2 over 1 is a fraction, so I just made it rational. So it's also rational. Yes. Is it irrational? Nope, it's not irrational. This is the only one it's not. It's not irrational, and it's real. Irrational numbers cannot be put in a fractional form. I just put it in a fraction, thus it's not irrational. So that's the answer for these 3 right here. Let's check those out. Good. Moving on. Clear this up. How many more do I have to do? 21 and then 22. Oh, good. I'm almost there. So we got to simplify this problem out. Remember, take your time. T-U-T. Take your time on this one. So can I simplify the top at all? No. Can I simplify the bottom at all? Nope. So at this point, because I can't simplify the top or the bottom separately, I'm going to start flipping. Bring things from the top to the bottom and the bottom to the top. So can I bring this 2 to the bottom? Nope. It doesn't have a negative exponent, so it stays up there. What about this x to negative 1? You bet I can. It becomes x to the positive 1. This y squared stays on top because it doesn't have a negative exponent. This x to the negative 3 goes to the top and becomes a positive exponent, and this y to the 4 goes to the bottom. Now that I have no negative exponents, I can start canceling over top and bottom. 2 really doesn't cancel, that stays there. There's 2 y's on top. I'm going to cancel those with 2 y's on the bottom, and I have 2 y's left over on the bottom. I'm going to cancel those. And there's 1 x on the bottom and 3 on the top, so I'm going to cancel 1 on the bottom, 1 on the top, and I'm left with 2 on top. And there's your final solution right there. Let's get that in there. I would put that in as 2x squared divided by y squared. 2x squared divided by y squared. Here we go. Holy cow. Let's skip that one. I'll come back to it though. Don't worry, I'll do it. Okay, I'll do it right now. I need some space for that crazy function. So we're going to do this function right over here. I'm going to focus on simplifying this part first. This beast. Then let me write it. I'm going to do the red part, or the purple part, and then I'm going to do this red part, and then I'm going to bring them together, and then I'm going to take the negative 1 in there. So let's do the purple part first. I'm going to take this negative 2 and distribute each exponent right here. Right there. So I got 3 to the negative 2 times x to the negative 10 times y to the negative 4 all over 2 to the negative 2 x to the 6th y to the negative 2. Okay? Now at this point, I'm going to flop anything with a negative exponent. So I got my 3 squared now is on the bottom, x to the 10 is now on the bottom, y to the 4 is now on the bottom, this 2 squared is now on the top, x to the 6 stays on the bottom there, and y squared is now on top. Okay? This is going well. I'm going to cancel. I'm going to bring these two together, and I'm going to cancel these off at the same time. I'm not taking my time. Hopefully it doesn't hurt me in the end. This is not my test, so I don't need to take my time as much. So y squared, okay, I got x to the 16 on the bottom, 3 squared right there, and then I got y squared on the bottom. So this is the purple right there. I just did the purple section. Okay, now let's do this red section right here. I'll bring this over here and do this. So I got y, if I bring this in there, to the 9 over, I've got to bring it there and there as well. So I got 2 to the negative 3, x to the negative 15. I'm going to bring all of these things on top. So I have 2 to the 3rd, x to the 15th, y to the 9th. Okay. Now, shoot, that should have been red. Let's make it right quick, just so you can kind of see what's going to happen here. Now we're going to bring these two together. This function right here. We're going to multiply them. Okay. So just imagine I have one nice big fraction bar right there. I'm going to cancel things off on top and bottom. So I got 15x's on top, 16 on the bottom. Cancel that with that. I got 1 left over on the bottom, right? I got 9y's on top, 2 on the bottom. That leaves me with 7 on top. I got a total of 5 2's on top, so that's 2 to the 5th. That doesn't change, and that doesn't change at all. Okay, so we simplified the total inside right here. We still have this negative 1 on the outside, right? So we still have that negative 1. So now everything really, what this negative 1 is just going to flip everything. Everything's going to become a negative exponent, and so it's just going to flip to the other side. So I'm going to have 3 squared x on top and 2 to the 5th y to the 7th on the bottom. Now I got to just figure out what these two things are. 3 squared is 9. Just run out of space. Sorry, everyone. 3 squared is 9 x. 2 to the 5th, 2 times 2 is 4, times 2 again is 8, times 2 again is 16, 2 again 32, y to the 7th. So there's your final solution. Nice and pretty. So we got 9x divided by 32y to the 7th. Please be right. Please be right. Please. Checking. No. No way. I'll check it later to figure out what I did. Oh! I put it in the wrong spot. That's what I did wrong. Okay, copy that. How about I put it in the right solution? Right here, where it's supposed to go. Now let's see if it's right. Yes! Okay. Oh gosh, that was heartache when I got that one wrong. Okay, moving on to this one, we got to evaluate the expression right here. This one will go nice and fast. Let's see if I can scroll down a little bit more. There we go. So I'm just going to take this 2, I'm going to distribute it into this exponent and this exponent right here. There are ones there, and we're going to distribute that and multiply. So I got 3 to the negative 2 times 1 is negative 2 over 5 to the negative 2. I don't like negative exponents, so I'm going to swap them. So I got 5 squared over 3 squared, and that's equal to 25 over 9. So my final solution would be 25 over 9, not this crazy thing that I have here. 5 divided by 9. Check. There we go. So that is how you do these problems right here. Hopefully this is helpful. Watch this tonight, figure out what you did wrong on your practice tests, and you should be ready to go tomorrow. The test is going to be upstairs in, I think, the north foreign room. Not the main one, but the north foreign room, okay? Everyone have a great night.